Coming up in our catalog of engineering catastrophes, a Dallas skyscraper with a dazzling design flaw.
On an 80-degree day, it's going to be like 110 degrees in the garden. It's already too hot here in the summer.
Historic Amsterdam is rocked when construction goes off the rails.
I heard just cracks, cracks.
An architectural error turns a Paris landmark into a blot on the landscape.
You go to Paris to see the iconic buildings, not to have them crash down on you.
And a small engineering oversight undermines an entire street.
And I could hear this rumbling. At that point, I realized the ground was moving.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, these are the massive engineering mistakes that only an expert can hope to fix. When complex constructions push the limits, it's not always easy to get it right first time. Some problems are hard to detect, while others are clear as day. For this story, we're off to the Deep South and Texas, and a design flaw the locals just can't ignore.
It's a 360-degree problem every day, every year.
The structure might be elegant and energy efficient, but the shining glass brings problems too.
It's like a disco ball. No matter where you are, there's light streaming into you.
This is disturbing.
Dallas, Texas, shining light of the Lone Star State. The Big D is one of the fastest growing cities in the U.S.
Texas is the oil capital of the USA, and its most famous city, Dallas, is hot, very hot.
With an average of 232 sunny days a year, summer temperatures can soar to 36 degrees centigrade. In 2013, the doors opened on the city's latest residential high-rise, the 42-story glass-clad Museum Tower. The shining facade was chosen for two reasons. Andy Scott later consulted on the tower's glass.
At the time, the choices of glass were made because they were beneficial for heat control and so forth inside the building, and were made for aesthetic reasons because it was beautiful and would look, beautiful from the distance.
It might look spectacular, but as Andy hinted, so much glass in a sun-baked city creates one very obvious problem: heat control. As the sun beats down on the huge wall of glass, the interior risks becoming a hothouse. This was no surprise, so engineers installed almost 25,000 square meters of special reflective glass to keep the heat out and reduce energy costs for residents. But midway through construction, local residents were in for a shock. The reflectivity wasn't just saving energy bills for the tower, as journalist Tim Rogers explains.
They want the glass to be reflective because it makes their job easier at Museum Tower. They don't have to spend as much money cooling the place, and they get to brag about how they're a LEED certified building, which is all well and fine. But that reflectivity has to go somewhere.
As gallery owner Petty Parker discovered to her horror, with her premises located directly opposite Museum Tower, halfway through construction, she noticed the startling effect the building was having.
Well, the first day we noticed the glare. First of all, it was an enormous glare coming not only from the building, but into our building and into our place, and unfortunately into our artwork. So that was alarming.
This is the last place you want a super shiny building. It's one of the sunniest places in the United States.
Usually it stays, the glare stays above about the 20th floor. It does go through to some of our paintings. We've moved a couple just to make sure. And so it's not your normal, oh, well, I can live with it glare.
The problem started right back in the design phase, when the decision was taken to build a skyscraper with an elliptical shape.
I found out that it's a 360-degree problem, not just one for us. So more neighbors noticed it, more and more people were noticing it.
Most skyscrapers are flat, so sun rays are reflected off in one direction. Not so Museum Tower. Consultant Charles Clift explains.
The geometry on the Museum Tower is complex. It's not only curved in plan section, it's also curved along its vertical axis. So the sunlight, no matter what time of day or what time of year, there is sunlight reflecting in lots of different directions. We have said it's like a disco ball. No matter where you are around the disco ball, there's light bouncing off and streaming into you.
With more than 2,000 panes of glass, each at a different angle, the effect is powerful. But the design is not ideal for its neighbors. Engineers have been constructing glass-fronted skyscrapers for decades, but as architects strive to create even more innovative designs, what might seem like a distinctive feature could turn out to be a major flaw.
The walkie-talkie in London is concave, like a satellite dish. It goes in, and so it focused the sun's rays into one burning point.
The Museum Tower has the opposite problem. It's convex like a ball, scattering the sun's rays, dazzling everyone around it.
It's not only an issue for residents in neighboring buildings. Museum Tower curves inward at its base, so the glare is also reflecting down to ground level, having a knock-on effect on an art gallery at the foot of the building, the Nasher Sculpture Center. Fulvio Serra is the designer and builder of the gallery's unique roof system.
Well, everything is special here. The architecture is custom designed. I would like to say that the roof basically is a sculpture in a museum of sculptures. It's modern art.
The Nasher Sculpture Center opened its doors in 2003, 4 years before Museum Tower was even proposed. Its glass roof, made of hundreds of thousands of tiny aluminum shells, was designed to create perfectly even light in the gallery, no matter where the sun is.
When the gallery roof was designed, they had no idea that a building was going to go up right next to it, which would become a light source all its own.
What should have been an artistic space filled with an even, diffuse light now suffers from secondary glare.
The holes that you see in the roof are allowing the light to get inside and to create an uniform light inside. When you see that the light can pass through the holes, like in that case, you see that the whole ambience is transformed.
Restoring the roof to its former glory would mean modifying every aluminum shell, not only labor-intensive, but hugely expensive.
Well, for arts lovers, I think it's a huge issue because the roof has been made utterly obsolete. So there are certain artwork that they can't even put inside the museum.
It's not just the interior that's affected. Next to the gallery is an 8,000 square meter sculpture garden, which has suffered under the same intense glare from the tower. Landscape architect Jeff Bruce was brought in to examine the root of the problem.
As you can see right now, I've got a bit of a shadow from the sunlight on this side of my face. But also on the other side, I've got a reflection of light that's coming off the museum tower in that location there.
This is really like having two suns shining down on everything.
Although the light is naturally coming this way, we can begin to see how it's bouncing off the tower and entering the garden.
But on an 80-degree day, it's going to be like 110 degrees in the garden. And that's not a pleasant experience. It's already too hot here, in the summer. We don't need help from another building reflecting light.
The double blast of sunlight from the tower has a negative impact on plant life and makes the gallery's garden areas so warm they're unusable by the general public.
Reflectivity isn't just about aesthetics. In many buildings, it's about keeping their green credentials by keeping their energy bills down.
If you can reflect the energy, the solar heat back out from getting into the building, that's sort of your first blunt force to reduce your energy consumption.
This concept was clearly a driving factor when it came to choosing materials for Museum Tower.
So this was the product that they chose for Museum Tower. 44% of solar radiation is reflected off of this building. That's what gives it that very bright, shiny, sort of light dancing quality.
This choice of glass was well intended, but there might have been a more neighbor-friendly option.
If you don't want that much reflectivity, you could pick this product. Reflectivity is only 16%. So it would have only 1/3 of the solar radiation reflecting off of this product compared to what was selected for Museum Tower.
One possible solution to Museum Tower's glare would be to replace the glass on the entire building with the less reflective option. However, there is one predictable hurdle standing in the way.
Money. It all comes down to money, right? I mean, both sides did their own studies to try and figure out what could be done about this, and people told me that it could be $20 million.
Total glass replacement, total curtain wall replacement on the museum tower, attaching, instead of just the glass, attaching a shutter and shade system to the museum tower.
One of the best solutions that I saw was a scrim, something that would go on the outside of the building.
Film was really going to be the best solution. At first, the film would last approximately 5 years. By the time we were done at the end of the study, the film was up to 7 years. Now I'm sure the film can last up to 10 years.
But of course, then the people who are buying these very expensive condos are going to say, wait a minute, I bought this condo for the view, and now you're going to put something that, obstructs that view? It's just a stalemate.
Sometimes buildings are built that are gorgeous and beautiful and wonderful, but you have to look at the effect it has on the community.
Engineers should always consider the environment, but it shouldn't come at the expense of existing businesses and residents.
Until a solid solution can be agreed on, Museum Tower's neighbors will simply have to avert their eyes and hope for the best. Engineers are constantly exploring new and radical ways to get the job done. But sometimes, even groundbreaking projects can turn out to be design disasters. For this story, we're off to the Netherlands, where an engineering challenge shook a city to its very foundations.
I heard cracks, cracks.
These houses have stood here for centuries.
The police and the firemen are standing in front of your door and getting your husband and your 3 kids out.
This is a nightmare scenario for a picture-perfect city.
Visited by 18 million tourists a year, Amsterdam is known for its artistic heritage, elaborate canal network, and narrow houses that have remained untouched, if a little bit uneven, for centuries. But in September 2008, cracks began to appear in homes in the VL Stra district at an alarming rate. Architect and landlord Volbert Vroom had just finished dinner when he received a disturbing phone call from his very worried tenant.
He said, I cannot open my door. It's just, I see cracks. I said, well, what's going on? And then I walked just, because I lived just around the corner, I walked and saw all those blue flashlights, police, firemen walking around. I thought, oh my goodness, it's happening.
Amsterdam resident Helena van Gelder was also caught in the middle of this housing crisis.
Helena, you had to come because there is something going wrong with the neighborhood, with the house in the next street. But okay, so I went just around the corner and I saw that the house of my neighbor was getting bad. It was sinking. And then another neighbor from the other street ran into me and said, Helena, the police and the firemen are standing in front of your door and getting your husband and your 3 kids out. Your house is going.
The houses are built on 400-year-old wooden piles, driven up to 20 meters down into a sandy bed. Dramatic subsidence on this scale is every resident's worst nightmare. Sudden movement or failure in the piles could easily lead to the collapse of a building.
I ran to my office and I could still open the front door. I heard just cracks, cracks. It was like the building was crying for pain. It was like it was sound everywhere.
That building is telling you, get out. The whole neighborhood is heading underground.
It was obvious the cause of the problem lay beneath the residents' feet, with a new infrastructure project the most likely suspect.
Amsterdam's famous for its bikes and canals, but there's a much faster way to get around the city, underground.
Amsterdam's metro system was nowhere near as big as other cities. It was just 26 miles long. Berlin's is more than 3 times the size, and Paris has more than 5 times the track.
In 2002, 5 years before the collapse, construction began on a new metro line with over 6 kilometers of tunnels running under the very heart of the city. Paul Janssen was the engineer in charge of boring the tunnels.
The new part is the north-south line, which connects northern part of Amsterdam with the southern parts. There is a big difference in boring a tunnel in our surface, our soil, compared to, let's say, the soil in England or Paris or the Alps.
The trouble is, the ground beneath Amsterdam is made up of peat, sand, and water. The bedrock lies nearly 400 meters below the surface and is unreachable for building foundations. Instead, buildings sit on piles driven to depths between 12 and 21 meters, which complicates the construction of any underground railway. And there's another problem: water.
Water was the making of Amsterdam, but it's also been its nemesis for centuries. The water table is so high in the city that building anything underground is never going to be easy.
Almost everything about Amsterdam is a potential construction nightmare. Sitting around 2 meters below sea level, with more canals than Venice, an extensive system of sea dikes, dams, and floodgates keep the city from completely flooding. So a project of this type was always going to be incredibly ambitious.
Building a metro system is going to be difficult anywhere, but if you add in Amsterdam's sodden soil, you've got one tricky engineering task.
It's a bit like trying to dig a hole in wet sand at the beach. As soon as you've dug it, the water just goes straight back in again.
Building of the metro system was a twofold challenge. First, find a way to contain Amsterdam's soggy soil as each section of the metro line was constructed. Then, avoid the intricate network of 11 million wooden piles holding up the houses in the city's historic center. Engineers came up with an ingenious plan.
The new metro line would follow the route of the city roads. If it didn't go underneath the houses, there's no risk of disturbing them. At least that was the theory.
Digging tunnels that only followed Amsterdam's elaborate and ancient road network was going to be restrictive.
So we had to avoid the piles of the houses and the buildings, but at some occasions we actually had to bore through the pile foundation.
Tunneling under the houses could potentially jeopardize the ancient city above. However, the engineers had a system in mind that would make it all possible. To minimize disruption above ground, before building each section of tunnel, concrete and steel walls were constructed on either side. These would separate the growing tunnel from the highly sensitive piles supporting the nearby houses. With a steel and concrete roof to support the road above, tunneling could safely continue. This is known as the box system. But in June 2008, as it reached construction of one of the underground stations, the project came to a dramatic halt. Michael Jonker, a spokesman for the Metro, explains.
Well, what happened at Vijzelgracht was that during the excavation of the station, the diaphragm wall started to leak water. But the water took sand with it, and the sand was just the thing where the houses were based on.
Tunneling only just below Amsterdam's historic buildings, the unique box construction specifically designed to protect these homes appeared to be destroying them.
In theory, the box system was an ingenious way of reducing the impact on the surrounding area, but it took just one leak in the concrete walls to cause utter chaos.
About 10 houses, they weren't livable anymore. So we had to restore that, but of course it was a big shock to the neighborhood, especially because it happened twice.
With work on the metro line back underway, in September there was a second dramatic failure in the box system.
Water and sand leaked into this construction zone, upsetting the delicate water table and those piles beneath the houses.
If water and sand leak into the tunnel, there's only one way for those houses to go. Down.
The construction team immediately stopped work and focused on securing the leak to protect the surrounding buildings. But for the historic houses above ground, it was already too late. They started to sink at an alarming rate.
So it was 25 centimeters, that's about 10 inches. We went down in 2 hours' time.
Then it happened again, and of course that was the moment that the city lost all the trust in the confidence in the project.
The cause for the failure remains unclear. It could be an undetected flaw in the box's foundations, a result of using new technology, or simply additional pressure placed upon the system while working so deep underground.
So a special commission had to find out, is it okay to continue this process? And they concluded, yes, it is okay, but mind your risks, take your measures, and improve your communication with the city.
Now, engineers are keeping a constant eye out for any settling. Using state-of-the-art laser sensors, Jaap Flink is managing this cutting-edge monitoring operation.
These are the instruments we used. We had 93 of them on the facades of every building. This instrument, through the lens you see here, attached to the front, sends out a laser to the mirror we have here.
The machine is placed on the front of a building, with the mirror attached to a house on the opposite side of the street. The machine detects even the tiniest movements, down to millimeters.
It sends out a laser. It's being reflected towards the machine, and the machine calculates the distance every time it measures this particular mirror. And by measuring it time and time again, you will be able to see if the building is moving.
The monitoring system is an ingenious way of making sure engineers are never caught out again. As the houses have stopped moving for now, the metro project has been able to move forward.
Without an instrument like this and the accuracy it has, within the typical Amsterdam conditions like soft soil, wooden piles, historic buildings, we wouldn't be able to build a metro line underneath this historic city.
After a series of delays, Amsterdam's new metro finally opened in July 2018. Above ground, engineers even managed to return the damaged buildings to their original condition. But this construction catastrophe wasn't cheap, costing over $1 million to shore up the houses with new concrete piles.
It's completely restored. You don't see any traces anymore. They also have lifted the whole building again up to the original before they crash. They have done a very, very good job.
The design problems mean the project will come in 5 years late and more than $1.5 billion over budget.
Even with the best laid plans, some places are never going to be ideal for certain building projects. But when talented engineers put their heads together, they can achieve the seemingly impossible.
In the pursuit of architectural perfection, the limits of engineering know-how can be stretched to breaking point. And when the elements and egos collide, the results can be catastrophic. Now to France, for a megastructure mess-up on a truly monumental scale.
This particular arch wasn't so triumphant.
Et le risque était d'avoir des plaques de 80 kg qui tombent de 100 mètres de haut.
You go to Paris to see the iconic buildings, not to have them crash down on you.
Paris, France, a city that's renowned for its art, culture, gastronomy, and of course, its architecture.
When you think of Paris, you think of the Eiffel Tower, the Louvre, the Arc de Triomphe, but there is another landmark that's more modern, but just as iconic.
Seen as a modern interpretation of the Arc de Triomphe, the radical Grande Arche de la Défense is a monument to the 20th century. In 1982, a great national design competition was launched by French President François Mitterrand. Danish architect Johan Otto von Spreckelsen won the commission with his design chosen for its strength and simplicity. Standing more than 100 meters high, the Grand Arch is a cube within a cube, designed to make an impact in the three-dimensional world. Robert Leon chaired the committee in selecting the winning design.
We call it La Grande Arche. It's sort of a crown on the business district. And also from Paris, I think it's nice to look at it. It's the horizontal line in a landscape where you have only vertical.
Mitterrand wanted a landmark building to honor his presidency. Rather than celebrate France's military victories, La Grande Arche stands as a monument to humanitarian ideals. An arch with 4 equal sides, this ambitious structure houses government offices within the 2 legs, while the roof section serves as an exhibition center and museum. It's an iconic feature on a significant route laid down in the 18th century.
We are on the historical axis of Paris, which comes from le Louvre, la Place de l'Étoile, l'Arc de Triomphe, and over to here and goes on west.
Work on the Grand Arch began in 1985. Constructed around a concrete and steel frame, the monument is topped by a vast 10,000 square meter roof, supported by concrete beams. The exterior walls are covered by 2,800 opaque glass panels and 350,000 gray and white marble sheets, engineered to be thin, light, and reflective. Von Spreckelsen specifically chose polished white Carrara marble to clad the east and west facades. Selected for its purity and reflectivity, the white Italian marble would catch the sun as it passed from sunrise to sunset. But von Spreckelsen's use of marble didn't come without controversy. Critics warned that it wasn't suitable for the Parisian climate, as historian Bernard Tullier explains.
Dès l'origine, l'architecte qui était danois n'utilisait jamais le marbre à l'extérieur dans son pays, c'est sûr. Et donc il pensait que la latitude française, l'Île-de-France, permettait d'utiliser le marbre. Ça flattait sans doute le président de se dire, dans mes grands travaux que je vais entreprendre dans ma présidence, je vais avoir une grande arche en marbre.
What is it they say about pride coming before a fall?
After various disputes, von Spreckelsen left the project. Sadly, he died in 1987, 2 years before his iconic design was completed. Work on the arch continued to meet the construction deadline of July 14, 1989, a date set to coincide with the bicentennial of the French Revolution.
1989 was the 200th anniversary of the French Revolution, with one important day, Bastille Day, 14th of July, and different monuments, this was one of them, had to be completed on that day.
Completed in just 4 years, the engineers had met their deadline, and the building was officially inaugurated the next day.
And the 15th of July was held here, a G7 summit with the heads of state from all over the world, President Bush, Mrs. Thatcher, and many others. So it was a very brilliant start for this building.
But while the Grand Arch was certainly an iconic structure, unlike its neighbor, the Arc de Triomphe, this newcomer was not designed to withstand the test of time. In fact, this monument to the modern age was about to take a dramatic fall from grace. In 2010, only 21 years after its unveiling, the controversial white Carrara marble tiles were showing signs of fatigue, leaving the Grand Arch in urgent need of repair. Stone has long been used in the construction of buildings and monuments, and known for its durability. These giant lumps famously stand up to the ravages of time. But von Spreckelsen's decision to use Italian marble was in fact the building's downfall. The thin marble cladding was no match for the Parisian climate.
C'était clair, le marbre n'était pas un matériau durable. Le marbre est poreux, donc l'eau, le brouillard, l'humidité rentrent dans le marbre et ensuite, avec le gel, il fait éclater le marbre. Donc, et à cette hauteur-là, un élément éclaté, ça représente un danger.
The white marble which covered the east and west of the arch developed serious defects. Cut into tiles about 4 centimeters thick, the marble panels absorbed water and began to bulge with changes in temperature, threatening to fall off their mounts in a process called granular debonding. Etienne Boss was the construction director for the remedial work on the Grand Arch.
En hiver, pendant les périodes de gel, le marbre se déforme et la décohésion granulaire a la particularité de faire que la déformation est définitive et s'amplifie tous les ans et de façon aléatoire. Donc les plaques de marbre, qui étaient des plaques de marbre minces de 4 cm, se déformaient de façon convexe ou concave, de façon indifférente, ce qui donnait une façade avec des vagues. Le vrai problème, c'est que les accroches de ce marbre se cassaient avec la déformation des plaques et le risque était d'avoir des plaques de 80 kg qui tombent de 100 mètres de haut.
This iconic building was in the limelight of Paris, not a great place for engineers to slip up.
Can you imagine being hit by a falling marble slab? It's unthinkable.
Mitterrand's vision had become an embarrassment, and in 2012, with 60 loose panels identified, the decision was made to replace the marble before any panels fell off.
A survey of the arch found that 1 in 6 of the tiles was loose. A solution had to be found.
Pour la rénovation et de la Grande Arche, on avait deux obligations. Respecter l'œuvre de Otto von Spreckelsen, l'architecte d'origine, et d'assurer au ministère la pérennité de ce qu'on allait faire.
Granite, known for its durability, was chosen as a suitable and sustainable replacement, with properties deemed to be risk-free and fit for purpose in the Parisian climate. To respect architect von Spreckelsen's vision, contractors sourced Bethel white granite from the US.
Replacing the marble with granite has cost the French public 200 million euros.
Work began in 2015. Contractors treated the surface of the granite so that it reflects light in a way that closely resembles the controversial Carrara marble, without the risks of failure.
Donc nous avions l'obligation de transmettre un bâtiment avec une assurance qu'on ne reviendrait pas dans 25 ans modifier ce que nous avions fait. Le granit, ça fait des siècles qu'on l'utilise, comme le marbre, mais les techniques modernes d'utiliser des parements de façade peu épais fonctionnent avec des granites et ne fonctionnent pas avec des marbres.
Granite was the best solution to this problem. The architect's vision had to be compromised slightly, albeit 20 years later, in order for it to survive to the 21st century.
While they may have found a satisfactory solution for form and function, the choice of replacement stone is not popular with everyone.
De substitution, je dirais, avec toute la dénégation que je peux mettre dans ce mot de substitution. C'était du marbre translucide, lisse, au toucher. Ici, la lumière ne joue plus avec le granit. La lumière ne joue plus avec l'aspect terne du granit.
It's very clean, very neat, and I'm very confident it will help the monument to last over centuries.
While engineering egos may have been bruised, in years to come, the Grand Arch will be seen as a monumental success and stand proud as an architectural icon of the Parisian skyline.
It's not only grand structures that suffer from dramatic engineering failure. Humble residential buildings can be hit just as hard, especially when the power of Mother Nature is underestimated. This next construction calamity takes us to England and a town shaken by what was thought to be an earthquake.
The UK is not known for its earthquakes. This was clearly something else.
I could hear this rumbling, and my natural instinct was to go out. At that point, I realized the ground was moving.
A minor engineering mistake caused a full-on catastrophe.
Ripon's residents were almost swallowed whole.
Ripon in Yorkshire, an ancient cathedral city, as steady as they come. In November 2016, residents of Magdalene's Road were safely tucked up in their 140-year-old houses. But late that evening, the peace was shattered. Ben Bramley was watching television.
Last night, about 10:30, a little bit drowsy, I've been watching the snooker, and my partner came and made me aware that there was a bit of a commotion.
Ben's neighbor, Francis O'Neill, had already gone to bed.
I think it was about 1:45, and I could hear this rumbling, and my natural instinct was to go out and went down what I thought were my steps down into the garden. At that point, I realized that the ground was moving. I luckily managed to pull myself back up.
A sinkhole the size of a school bus had swallowed their back gardens.
I guess it didn't really dawn on me at first how serious it was. It was only when I went around the back of the house and got a different perspective, a different angle, that you could see the depth, and it was right up within 10, 15 feet of our back door.
With the properties in serious danger of falling, firefighters gave the residents just 15 minutes to pack their bags and leave. The collapse shocked the city, and yet, this wasn't the first sinkhole in the area. Dr. Anthony Cooper has been studying Ripon's unstable history for over 30 years.
Well, sinkholes in Ripon have been recorded for over 100 years. The Reverend Toot wrote a paper in about 1868. The survey geologist that came here wrote another paper in about 1870. And they documented a lot of sinkholes. Compared with elsewhere in the country, there are more sinkholes in Ripon than there are in a lot of places.
And it's not just sinkholes.
Several houses that were built along the road here had to be taken down due to subsidence. The ones further on the right have got a big sag. These ones on the right are tilted backwards. There's one there that's been demolished.
This is not a coincidence. There is definitely some kind of pattern here, and all the evidence is pointing towards Ripon's geology. There is definitely something going on beneath their feet.
Ripon's problem is that it sits above deposits of the chalky mineral gypsum.
This is gypsum, fibrous gypsum, porphyroblastic gypsum with big crystals in, and a bit of muddy gypsum. And if I put this in the river, it would only last about a week before it dissolved away completely.
For thousands of years, rainwater has been dissolving the pockets of gypsum around Ripon, gradually creating caves deep underground. As the caves grow, their ceilings collapse, forming sinkholes. 140 years ago, where these gypsum deposits lie was anyone's guess, on top of which, in Victorian times, building regulations were lax, with shallow foundations less than a meter deep. Builders would never have known if there was a dangerous seam of gypsum hidden below.
That's the big thing with sinkholes. They are hidden underground. The first time you sort of know that they exist is when they're sucking your garden into them.
Magdalene's Road sits on a seam of gypsum, but the sinkhole here was very localized, with no evidence of other caves nearby. It seems Mother Nature might not be entirely to blame.
The area has a history of leaking drains and blocked up drains, and it's a bit of a chicken and egg situation. Does the sinkhole collapse slightly and break the drain, or does the drain leak and wash material down that then causes the sinkhole?
Worn with age or damaged by tree roots, a cracked drain pipe will leak water into the surrounding subsoil. If the leak is close to a building's foundations, it can have a devastating effect. With the damp soil unable to hold the weight of the building, the walls begin to sink into the softer ground, causing cracks to appear.
A water leak above ground is bad enough, but if you've got one underground in a sinkhole area, well, that is going to be a disaster.
Whatever the cause, local officials in Ripon keep a close eye on any suspicious movement. Since the Magdalenes Road incident, nearby residents noticed a dip in their local park. Dave Morgan, a geophysicist from the British Geological Survey, has come to investigate.
I'm going to be taking readings here every 10 meters along what I assume is solid ground at the beginning of the line, through the center of the feature here. Now I'm standing in the bottom of it. So the assumption is that there's weaker ground under here, possibly a void at greater depth, and the ground is slowly sinking into it.
Dave is essentially performing an X-ray to find out if this is just a dip in the land or whether an underground cavern is forming.
I think it's important to do these tests because we can identify areas which are likely to undergo collapse, and the civil engineering companies can mitigate that, and they can put the correct foundations in for new buildings to ensure that they're safe.
Dave's using an additional piece of kit in his testing, a graviton.
A graviton measures the strength of gravity in the ground beneath it. The less dense the ground, the lower the reading, and vice versa.
24 hours later, Dave is back at headquarters with the results of the tests.
What I have on the screen now is a display of the survey we did last December and the one we did yesterday. We have an area of dark blue here on both surveys, and that corresponds with the weakened area. On either side of it, we see lots of warm colours, the oranges, reds and purples, corresponding with the stronger rocks either side. So our interpretation is that that is a weaker zone which is falling in.
The darker blue circle clearly shows a vulnerable area. But has it gotten any worse since the last survey?
There are subtle changes, and I've noticed smaller areas in the yellow colours close to the surface here are not so apparent on yesterday's survey. So we might conclude from that some of the rocks near the surface have weakened to some degree. So it does indicate that things are changing.
Dave will continue to monitor the area for signs of movement, but it's too late for Magdalenes Road. With the suspected leak fixed, it was time to plug the hole.
The engineers have put in a large plug of concrete to remediate the ground.
The best solution was to fill the sinkhole with reinforced concrete. Seems simple enough, but it actually took months.
With engineering mishaps, sometimes the solution needs to be simple and robust. But when it comes to sinkholes, the real key is knowing exactly what lies beneath.
So the residents of beautiful Ripon are safe for now. I just hope those underground caverns stay exactly where they should be, underground.
Construction calamities come in all shapes and sizes. So long as we keep building, there will always be more blunders to fix.